If you are thinking about a career in engineering, but you don't understand what an engineer really does day to day, then you're in the right place. Because today I'm going to explain what an engineer really does and what types of engineering roles exist, something that you're not taught in a standard university curriculum. Today, it's just a real engineer with real insights. My name is Josh, and this is Engineering a Better Education. I want to start by saying that even though I work as a full-time engineer, I used to have no idea what an engineer really was. In fact, when I was in high school, I didn't have a clue. None of my siblings or my parents or aunts and uncles are engineers. So the place where I had primarily heard the term engineer was in video games, actually. And it was like you could choose between different types of characters, like a medic, a gunner, an engineer. And these were like war video games. So my perception of an engineer was that it was actually a type of soldier. So that tells you where I was coming from when I was in high school and maybe the age of some of you who are watching this video. And so engineering never really stood out to me. I didn't have intentions of going into the military or being a soldier, so I thought I don't want to be an engineer then. And furthermore, one of my best friends, his dad is actually an electrical engineer, and I don't know exactly what his role was, but he worked for Verizon, and it may have even not been an engineering role at the time he was working this job, but he would be on the phone all day with customers. And so I thought that being an engineer meant that you would be on the phone all day, and I didn't like talking on the phone. So once again, engineering never crossed my mind, wasn't even on my radar in high school. Most high school students today probably have a better understanding of what an engineer is than I did at their age. So that tells you where I was coming from. And then furthermore, once you get into college, and ironically, I chose an engineering degree as my first degree when I first started college. And the reason I did that is because I literally just spent hours on the university website of the school that I had chosen. And I just looked through like all of the majors that they offered, and I read the 1 to 2 paragraph description about all of the majors. And I actually landed on engineering because I was like, oh, I like math and science, and it seems like I'd get to take a lot of math and science classes. So I wish that when I was in high school, I had a better understanding of career options and that I knew what an engineer actually is. And so I'm happy that you're listening today, and I hope that you'll walk away with some really key insights and feel more clarity about your future. But the problem is when you get to college, they divide out the types of engineers by area of expertise. So it's like you can be a mechanical engineer if you want to work with hardware, mechanical systems. You can be a biomedical engineer if you want to work with medical devices and be more on the biology side. Or you can be an electrical engineer if you want to work with circuits and electrical hardware. And the problem is this still doesn't tell you anything about what an engineer will be doing day to day and what types of roles exist. That's what I'm going to go over today. And I want to use a really clear, concrete example. So imagine you're riding an electric scooter downtown in the city, and as you're riding, it suddenly just shuts off. And that's not only inconvenient to you as a user, but that's dangerous. If you're going 15 miles per hour on an electric scooter and it just shuts off all of a sudden, you might go flying off, you might break a bone, you might get injured. And so imagine this happens to you and you're thinking, who is responsible for this? Who designed this scooter? Like, what mistakes were made that led to the point that I would just be riding this scooter and it would shut off all of a sudden? And I'm going to answer that question today. And it turns out it's generally not just one person who's responsible for the design of a product. It's actually a system of engineers and a team of engineers with complementary but distinct and overlapping roles. So I want to start by talking about how this electric scooter might have been designed from beginning to the moment you were riding it. The team of engineers that worked on this scooter could be broken down into 6 different roles, and I like to visualize these 6 roles as a 2x3 matrix. And on one axis, you have the stage of the product. So on one side, you have the development stage, And on the other side, you have the sustaining stage. One is early stage, it's before the product goes commercial, and the other is after the product goes commercial. Yeah, something interesting that I didn't know was that you actually have engineers working on products that are already commercial, that have already been launched. On the other axis, you have distinct roles and authority within the design process. And we call the early stage new product development typically, and the post-commercial stage the sustaining stage. So you are sustaining a post-commercial product. And then on the other axis, we have these three roles: R&D, which stands for research and development. We have manufacturing, and we have quality. And the way that these three roles interact with each other, I actually like to visualize like a triangle where you'd have quality, R&D, manufacturing. It doesn't really matter. It's an equilateral triangle. You can rotate it any which way. And in any case, each role interacts with the other two. So if you take this 2x3 matrix, as I've explained it, then you have the new product development, research and design engineers, which can be abbreviated as NPD R&D engineers. Then you have NPD manufacturing engineers and NPD quality engineers. On the post-commercial side, you have sustaining research and development engineers, sustaining R&D engineers, sustaining manufacturing engineers, and sustaining quality engineers. So let's walk through this example of an electric scooter, how it might have been designed, and what would be the contribution of each of these types of engineers. So if we go all the way back to before the scooter was even invented, we would land with our NPD R&D engineers. That's new product development, research, and design engineers. These are the engineers who would be most heavily involved in the early conception phase of the product. They would have identified a problem, which would be people downtown find walking too slow and they need a faster mode of transportation. That might be one of the problems or the problem that this business is trying to solve. And let's break down kind of 5 main components of this electric scooter. One would be the battery. That's the source of energy for the scooter. Number 2 would be the motor. That's what gives the wheels the ability to turn. We'd have the controller, which is like the brains of the scooter. It would be the circuitry that would make the decisions about how to control the motor and how much energy from the battery to deliver to the motor. So that's the controller. Then you'd have the brakes. That's really important. Can't stop without those. And lastly, the frame, which is like the part that you stand on and what holds everything else together. So as an NPD R&D engineer, you would be making design choices about how long should the battery last? What type of battery should we use? How quickly do the brakes need to stop? What type of braking system do we want to use? What is the frame going to look like? How much weight will the frame support? What size of person, height, and weight will the frame support? It's all of these design questions. So their role is to invent the product. That's their main function. But of course, while they are working on inventing the product, they're going to be communicating and collaborating with the NPD manufacturing engineers and the NPD quality engineers. Once the R&D engineer has invented the product, let's say, then it goes to design transfer, where the concept of this product would get designed to our manufacturing and our quality team. And the role of the manufacturing engineer, specifically new product development manufacturing engineer, is to figure out, okay, we've made a few prototypes of this product. Now, how can we make 10,000 of these or 100,000 of these or 1,000,000 of these? And how can we do it consistently and inexpensively? Because the more it costs to manufacture a product, the more expensive that product needs to be in order for a business to sustain itself. So the manufacturing engineer would decide, what manufacturing methods are we going to use? Are we going to hire a bunch of human operators that are going to assemble these pieces together and screw them together with an electric screwdriver and mount all the components? Are we going to design machines that will manufacture these components together? And most manufacturing processes are actually a combination of those two. I think a lot of people envision manufacturing as machines doing the work, but in fact, a lot of humans are involved with manufacturing the products that we see every day. And they're just trained to do a specific process, a specific task over and over on a manufacturing or an assembly line. So the manufacturing engineer is going to make decisions about how do we build this. And while the R&D engineer was designing the concept, there would be frequent touch points with the manufacturing engineer so that the R&D engineer makes sure they design something that can be manufactured at scale and that can be manufactured inexpensively and consistently. The quality engineer has the role and the responsibility to make sure that the product we're building and sending out the door is high quality. They are the ones thinking about things like the scooter stopping suddenly. Like, what are the risks involved with this scooter? They would be defining a risk matrix where they say, what are the possible harms that could occur to a user of this scooter? How might they occur? So the brakes failing would be an obvious risk to consider. The controller just shutting off, the motor stopping, things like that. Also risk to the user, such as the battery life just not being long enough for people to get to the destination that they're going to. So that would be the role of the quality engineer, and they would also think about quality of the manufacturing process. If we have a lot of uncontrolled manual processes where we're just taking a human that we're hiring off the street and we're expecting them to correctly assemble the electrical components inside the scooter, are they going to do it right every time? How are we going to check and verify that it was done right every time? So a quality engineer is going to design a lot of the inspection processes on the manufacturing line. And yes, you do need to inspect products that you're manufacturing. And what that might look like is hiring, once again, a human to look over the components, make sure that every component is present. Because once again, if you forget something, like maybe you manufacture a scooter and someone forgot to put the brakes on. If you don't have an inspection point in your process, you legitimately might not notice that a manufactured product is missing a component. So as a quality engineer, you're setting up your inspections and you're ensuring that every product that goes out the door meets your quality standards. And once again, the quality engineer is going to have regular touch points with the R&D engineer during design, because where the R&D engineer is going to come up with a concept, they're going to have to present it to their manufacturing engineer and quality engineer and get their sign off and their buy off on that product. And the quality engineer, essentially, they're saying, okay, you've told me you have a design that works and that is safe and effective. Now prove it to me, or how are we going to prove it? So the quality engineer would be heavily involved also with the tests that you would put the design through. Even before you go commercial, you need to test your prototypes. And if you're not doing the right tests and you're not asking the right questions, then you won't know whether the design is actually good. So just to break those three roles down one more time, R&D is responsible for inventing the product. They're going to make those initial design decisions. How are we actually going to solve this problem? What is the design going to look like? The manufacturing engineer is responsible for how are we going to build a lot of these for an inexpensive cost and with consistent quality. The quality engineer is how do we make sure that every product that goes out this door is good, that it's safe, it's effective, it meets all of our requirements and standards. And the quality engineer is going to be asking those questions about the manufacturing process. So they're going to be asking, what inspections are we doing on our manufacturing line to make sure that every step of manufacturing was done correctly? And they're also asking, how do we know that the original design is meeting our quality requirements? So what tests do we need to perform on our design before we even start manufacturing it to make sure that we've proven that the design is good? So those three roles, that's what they would look like in the NPD new product development space. But let's go back to that example that I brought up at the beginning of this episode, which is you're riding a scooter and suddenly it shuts off and you go flying forward. and you call up the company, you file a complaint with them saying, I was riding your scooter, this happened to me, and somebody on the phone or the email is going to collect all the information, and they're going to send it back to their sustaining engineering team. So once again, sustaining is the stage after a product goes commercial. And this scooter that we're talking about in this example has already gone commercial. People are riding it. So we have an R&D sustaining engineer who is responsible to fix and improve the design after launch. So yes, you can launch a product and still make changes to it, but it has to be controlled and well thought out. So that's why we have these sustaining engineers. So the R&D team is going to be the ones who investigate the issue that occurred. Maybe if you're a customer who got hurt on one of these scooters, they would ask, can you please ship the scooter back to us? Or they'll ask the company that owns the scooters to send it back. And it's going to arrive at an R&D sustaining engineer who might open up this scooter and look at the components, make sure that nothing was damaged, figure out what the root cause of this failure was. And once again, they'll be collaborating with the sustaining manufacturing engineer so that they can figure out, was this failure caused by a design issue or a manufacturing issue? So the sustaining manufacturing engineers are going to be experts on the manufacturing process and can help answer that question. And then they'll also be collaborating with the sustaining quality engineer who is going to have a good understanding of the risks involved with the product and who is regularly monitoring the real-world performance of the product. So the role of that sustaining R&D engineer is to fix and improve the product after it has launched. The primary role of a sustaining manufacturing engineer is to ensure that the production line continues running smoothly. So there are issues in manufacturing lines that pop up daily and weekly of varying scales, complexities, and severity. On a day-to-day basis, something might come up. One of the pieces of equipment that you're using on the manufacturing line may go down, or you may start seeing some sort of new defect on the manufacturing line. This is where the manufacturing sustaining engineer comes in and investigates the issue. And manufacturing lines do not have 100% yield, meaning that 100% of the product they manufacture does not actually make it to customers, because if a defect is created during the manufacturing process, like a component was forgotten, or during one of your inspections, the criteria wasn't met, then you would actually throw away that product. Sometimes you can rework it, which means to send it back to a previous stage on the manufacturing line and basically repair the issue, but that's not always possible. So when product doesn't meet all of the requirements, it gets scrapped. Manufacturing engineers are looking at yields, the yield of the manufacturing line daily, monthly, quarterly, and trying to improve that yield and deciding what changes can we make to our existing manufacturing process to make it better. So the NPD manufacturing engineer set up the initial process, but as you start producing thousands or tens of thousands or hundreds of thousands of units, you figure out that there's a better way, and you figure out what the shortcomings of the manufacturing process are. That's where the sustaining manufacturing engineer would come in and improve that process. The sustaining quality engineer is going to monitor the quality of the product regularly. So they're going to be collecting data from the inspections and the tests that you do on the product. So in the case of the electric scooter, you may pull a few samples off of your manufacturing line every week or every kind of batch of scooters that you make, and you might even do destructive testing on them. You want to make sure that the brakes really are working, and so you might actually set up a test where you push the brakes all the way to failure. So maybe you've devised a test where you can actually figure out the limits of the brakes, like what would be the maximum amount of force that the brake pads can apply or something like that. And so you're actually you're building these scooters and you're destroying them, maybe just a few of them with every batch, and you're verifying that everything was working with them and the frame was strong enough. Maybe you in order to find out how much force it takes to break the frame, you'd need to break the frame with some piece of equipment and measure that amount of force. And you'd be collecting this data, and a quality engineer would be regularly reviewing this data and seeing, is there a drift in our manufacturing process? Did we all of a sudden see that our average break failure force is lower than it used to be? Then that would indicate a problem on our manufacturing process. So the quality sustaining engineer would collaborate with the manufacturing sustaining engineer to investigate that root cause. And then the quality sustaining engineer, typically is responsible for implementing corrective actions. So whatever comes out of an investigation, you figure out what the root cause is, and then you implement corrective actions that are going to change something so it doesn't happen again. Of course, an electric scooter manufacturer does not ever want their scooter shutting off randomly and sending a customer flying forward and getting injured. So if that ever happens, then they're dedicated to investigating the problem and ensuring it doesn't happen again. If you investigate and figure out why it happened, but you don't implement any corrective actions, then it's just going to continue to happen, and it's going to happen again. So that's where your quality sustaining engineer is very important, is they kind of collect and analyze all of this data and decide what corrective actions do we need to implement to make sure this issue doesn't repeat itself. So just to recap those 6 roles, we have NPD R&D engineers, where their role is to invent the product. We have NPD manufacturing engineers, where their role is to figure out how we can build this product at scale. We have NPD quality engineers, whose role is to make sure the product works before launch and make sure that it's safe and effective. Then we have sustaining R&D engineers, whose role is to fix and improve the product after it has launched. We have sustaining manufacturing engineers, whose role is to make sure that the production line continues running smoothly all the time and to improve the yield of the manufacturing line. And then lastly, we have sustaining quality engineers, whose role is to monitor the real-world performance of the product and to implement corrective actions as issues come up with the product. So as you can see, every product is built around a system and a team of engineers, not just one individual engineering role. And in college university degree, they generally do not explain the difference between these roles. And this is what defines what you really will be doing day to day in your job. The university differentiates engineering by the expertise that you have, but not by the role that you have. So when I graduated from college, I actually didn't understand the difference between these roles, and I kind of just took like the first job that opened up, which happened to be a sustaining manufacturing role. And I'm actually now in an NPD quality role. So I've had some intimate experience with both of those roles, and I can say I did not understand the difference between them when I was in college, and truthfully until I worked those roles. But I want you to be able to understand earlier on what these types of roles are and to figure out what you're most interested in. So if you've enjoyed today's episode, I invite you to leave a comment below answering the question, which of these 6 engineering roles are you most interested in? And tell us why. I hope that you've learned something today, and I can't wait to chat with you again soon.